as a youngster on an Indiana farm. His curiosity about the weather led to a BS in meteorology from Purdue University and a 35-year career as a weather forecaster. Within the AccuWeather forecasting team, Dan holds the rank of expert senior meteorologist, AccuWeather's highest distinction for an operational meteorologist. This designation is awarded to those who earn certification in both live on-air radio and live on-air television broadcasting, and who hold leadership roles within the company's severe weather team. Dan leverages both his in-depth understanding of the weather and his top flight communication skills throughout the year as AccuWeather's Director of Television Franchise Services. In this role, Dan is responsible for daily briefings of television meteorologists at some of the most viewed affiliate stations across the country. Dan's briefings combine details on the developing weather situation with advice on presentation strategies that will most effectively deliver forecasts for the station's viewers. During the Atlantic hurricane season, Dan wears an additional hat as the lead hurricane forecaster for AccuWeather. He coordinates the AccuWeather hurricane team and frequently appears in the video media as an expert in hurricanes and related service weather, or severe weather, excuse me. Dan's stature in the hurricane forecasting community led to his selection in 2011 for a special appointment at NOAA's National Hurricane Center. Dan served as an advisor to the Forecast Improvement Program, a NOAA initiative that sought his expert insight and ideas on how forecasters and researchers at the National Hurricane Center can improve communication to the general public and create more timely products and services. Dan and his wife Karen have a son who is a pilot in the U.S. Air Force and a daughter who's a graphic designer. After Dan's presentation, we'll be hearing from Claudia Dent, Vice President of Product Management at Everbridge. Claudia brings many years of experience in the technology industry, including executive positions in product management, marketing, business development, and general management in companies ranging from startup to large global enterprises. We are excited and honored to have both of our speakers with us today. And now I'd like to turn it over to our first presenter, Dan Kwiatkowski. Dan, you may begin.
Okay, Aaron. Yeah, get my screen up here, and we'll start up. I want to welcome everyone to this presentation here. We'll be talking again mostly about the effects of hurricanes on how we can mitigate the damage and how we can deal with the actual, what I call the hurricane problem then. So starting off here, we'll talk about definitions and what actually is a hurricane, and talk about where hurricanes affect not only the United States but also other parts of the world as well then. So basically, a hurricane basically is the largest and most destructive storm system on Earth. The average diameter is roughly about 310 miles. There is an eye. I'll talk about this in a little bit here when we look at satellite images. We get the most intense part of a hurricane in what is called the eye wall. That's where all the real deep thunderstorms are, and that's where all the wind is located, the strongest winds in. And the lifespan of a hurricane is only about a week long. Some do last longer and some do last less. Again, dry air, colder water, and strong upper level winds are the things that really cause these big storms to weaken. Intense, again, when we look at tropical cyclones as far as comparing them to other parts of the world, all tropical cyclones, which include the hurricane, that reach 64 knots or 73 miles an hour are considered either a hurricane or called a typhoon or maybe a cyclone in India or a tropical cyclone in Australia. They're all the same thing. Typhoon is the same thing as a hurricane, just a different name then. But this is an image of Hurricane Dennis taken in 2005 in July. The little dot in the center there is what we call the eye of the hurricane right through here. The eye wall is around the outer periphery of the actual hurricane. This is an image just as Hurricane Katrina became a Category 5 hurricane back in 2005. Again, the image is taken from a satellite which is located on right over the equator and roughly right about 75 west. So that's why we're able to see an angle of this thing in the Gulf of Mexico. I'll show you an image of a hurricane where you can actually see 4 distinct what we call mesocyclones, or what we would call mesocyclones, which produce tornadoes in the plains. that are dancing around the center of a hurricane. When a hurricane gets this size, the amount of energy and the amount of destruction it can create is phenomenal then. Here's another hurricane. This is Hurricane Rita, also 2005. This struck, moved inland just near Lake Charles, Louisiana. And then again, you can see that it has sort of what we call a stadium effect. We can kind of see the eye, and it kind of comes down like in a funnel. This is a really beautiful looking storm, even though it is a very destructive storm. Also, what you see around the storm is what we call cloud drift winds, wind tags, which allow us to understand the wind flow around a hurricane. This is where satellite imagery becomes so important to us in monitoring and understanding what the hurricane is doing then. A vertical profile of the hurricane looks as follows. You'll see again that you have the eye, which is the middle through here. The outer rain, we have what is called outer rain bands. You have alternating upward motion, which causes precipitation to occur, and downward motion, which actually causes less precipitation. But in the eye of calm here, the air is actually sinking through this area. So that's the reason why we are able to see the eye in a hurricane dam. Now, the number of tropical cyclones, again, these can be either a tropical storm or a hurricane or even a depression. These are the numbers, approximately how many tropical cyclones we see in a given year. So as you can see, the Western Pacific have an average of 26, while here in the Atlantic Basin, we have an average of 12. On the other side of Mexico there, in the Eastern Pacific, we have a number of 16. So the United States is actually impacted by two different basins here, the Atlantic Basin and the Eastern Pacific Basin. And again, if the track of the storms are correct, we can be impacted quite a bit more in some years, more than others then. But worldwide, we have an average of 86 per year. What's interesting, that number has not changed through the last 100 years as far as we can tell, or at least when we started taking satellite imagery of the world back in the 70s, this number has been pretty constant. Now, storms, hurricanes and tropical storms can move in erratic paths, and these are the ones that causes the biggest problems. And these also are can be more difficult to forecast. So just want to point out to you that not every hurricane has a nice smooth path. A lot of them get stuck. The winds in which they're embedded in do slow down, and sometimes that can cause the hurricane to weaken or sometimes move back and forth. So again, just want to point out that all hurricanes are not equal here. Now, this is a map showing all the known tropical cyclones that have ever occurred in the satellite era. And you can see a lot of them. And again, the purpose of hurricanes in the atmosphere is to balance out the amount of heat buildup in the tropics and try to transport that into the more northern latitudes. That's the reason why you see so many of these storms across the world like this. You can see areas that are affected by it. You can see China, Japan. But look how they affect the United States here. Again, pretty widespread, as you can see, if you spread them all out. A lot of chances for impacts along the United States, also in the Caribbean as well. Now, in a hurricane, when you're looking at how the structure is and how a hurricane affects a coastal area, the strongest winds are in the right front quadrant of the storm. So if you're looking at a storm, right front quadrant is where the strongest winds are, because the winds have to come around onto land oftentimes and come around on the back side or on the left side of the storm. And this causes friction and causes the winds to slow down. So in the case right here of Gloria back in 1985, you had a difference of almost 50 knots of wind. Knot is approximately 1.15 miles an hour, so about 115 mile an hour wind on the east side, and roughly about almost 60 miles an hour on the west side. So when a storm moves up the coast, the damage on a storm like this is going to be much less from the wind because of the fact that the winds are on the right side then. So that's always something you want to keep in mind when you're looking at the movement of a tropical storm or hurricane then. Now, as far as conditions favorable for development, you start out with a disturbance that develops a nice circular look to it. Warm water is a must in these storms, and you want the winds to be blowing in the correct direction. If they're not, that causes the thunderstorms to go in a wrong direction as they build aloft. So those winds are very, very important. Dry air is also a detriment to development or intensification. Sometimes dry air does not kill a hurricane. It just keeps them from strengthening. And so dry air is a very big factor in looking at this. And also, we notice that when the surface pressures across an area where there's development taking place, when the pressures are lower, that allows the storm to wrap up much quicker then. So we classify the stage of development as follows. We start out with what we call an easterly wave, where there's no organization, just a bunch of clouds moving in the same direction, usually in a linear looking. They look kind of like north-south or northeast to southwest orientation. Then we develop what is called a tropical disturbance, where the thunderstorms start becoming a little bit more organized or somewhat more rounded in nature. You get more of a rounded blob developing. And then you get into what is called a depression, where you actually start seeing the clouds rotating over a common center. Once those winds reach 39 miles an hour or higher, up to 73 miles an hour, we classify that as a tropical storm. That is when we name the storm. We name the storm once the winds get to 39 miles an hour or higher. We do not name tropical depressions or disturbances, although once a storm once they're downgraded to a depression, we will maintain their name. And once a storm reaches a hurricane, those winds have to be at 74 miles an hour or higher. And again, we'll talk about categories here in a second. Now here's a montage of Hurricane Dean back in 2007. Again, you start out with a blob, or almost a north-south orientation of clouds, showers, and thunderstorms. It becomes more rounded. As you go to the storm, you get a nice rounded look. You start seeing the clouds kind of wrapping in a common center. And then once those clouds wrap around and a hole develops or an eye develops, that's a sign that a hurricane has developed or is evolving in a storm like this. So 9 times out of 10, when we see an eye developing, we name it. We actually upgrade this to a hurricane. As you can see, as a hurricane works westward, if it's over open water, it'll continue to intensify. So you'll notice the eye gets more vivid over time. And even if it goes over a small piece of land like the Yucatan, which does not have a really impressive terrain effect, it will still redevelop on the other side as well. So hurricanes, again, are big, big storms. And here's a montage of Hurricane Irene. Now, Irene, this is 2011. Many of you remember Irene from the flooding it caused, but you'll notice, again, you don't see much of an eye in this. And Sandy was the same way. We did not see much of an eye in the storm. And usually weak hurricanes, the eye appears and disappears quite often. Now, we use a number of tools at AccuWeather. I just want to point out, because of technology, we have access to all the information that all the different hurricane centers across the world have. We have access to all the data, reconnaissance aircraft data, radars, computer models, and, of course, historical information. And again, intuition is also an important role in this, because the more you work with these storms, the more you understand their nature then. Now, let's talk a little bit about hurricane intensity. Hurricanes intensify as clouds build up. They give off heat, and as water vapor condenses. So you're talking about a warm storm system here. Storms that move across the United States from west to east, especially during the winter, are called cold core systems. Hurricanes are called warm core systems. If the upper level structure of a hurricane vents, or the air is allowed to come out of the top very easily, and you have enough warm water, both that upper level and the lower level, when they're in synergy like that, that means that we have a very well-organized system. And that's what we look for when we see a hurricane intensifying. Now, as I said earlier, a storm has to reach 74 miles an hour to be classified as a hurricane. Hurricanes are rated on a scale of 1 to 5, where 5 is the most intense hurricane with winds in excess of 155 miles an hour. Now, anything rated as a 3 or a Category 3 hurricane is called a major hurricane. The reason why we distinguish that, because once you get to a Category 3, the wind flow around it is such that we see major damage from hurricanes. It's not that a Category 1 or 2 does not create damage, because it can. We saw from Sandy, for example. Sandy was only a Category 1 hurricane, and even though it transitioned to a non-hurricane, the large volume of water it forced into the water or into the coastal areas was, again, a huge, huge factor in causing the extensive damage that it did. Now, as far as Category 5 hurricanes are concerned, there's only been 3 to hit the United States. Again, the key word there is hit, because we've had several hurricanes, dozens of hurricanes that have reached Category 5 out in the middle of the water. Labor Day hurricane 1935, which hit the Keys, Camille, which came into Mobile Bay, and Andrew, of course, which hit the Florida area just to the south of Miami, and Homestead, then hit Morgan City, Louisiana in 1992. Those are the only 3 that have been ever classified as a Category 5 making landfall in the United States. Now, you will have access to these slides, and I don't want to spend a lot of time on this slide because it's very, very interesting. But the point is, we do classify these hurricanes. If we don't have a plane in there to look at the actual storm, then we will use satellite imagery to help us understand the intensity. And that's what these satellite images show on here. So you can look at different categories. I do want to point out, however, that we continue to use names, the same name, year after year, unless it's a very destructive hurricane. For example, this shows Katrina back in 2005. You will never see another Katrina show up on these storms, but you may see another storm that may show up that's a very impressive one. Fortunately, all these named storms you see here, their names have been retired because they were very destructive or they caused major issues. So now let's talk about risks to lives and property. The hurricane problem, as I said earlier, centers around loss of life, damage, and then storm surge, flooding, damaging winds, basically a disruption to life and business as we know it. And again, the numbers have gone up, so we'll address those situations. Loss of life. If you look at this graphic here, you'll notice that basically, if you don't look at Katrina, you'll notice that most of the people who died in hurricanes or the bigger death tolls occurred way, way long ago when we didn't have the proper communications. But Katrina was very unusual from the fact that we had all these communications in place, yet we had a phenomenal number of people die from this. So that still is an issue, and still that's something that we have to settle on, because if a major storm, major hurricane, like we had with Katrina, hits the coast and hits a large populated area, will our communications be able to get the people out of harm's way? Will people believe us? And that's an issue. We also have to worry about the damage, and that's something that has continued to go up. More people are building along the coast. We have a bigger population now than ever before that live closer to the coast. That's put people's structures, people's homes and businesses in harm's way, and the cost of living continues to rise. So that's why these numbers continue to rise. If a hurricane hits a major metropolitan area, you're going to have a major cost in damage from such a structure. The biggest issue with hurricanes is storm surge. Storm surge, basically, to put it simply, is a large pileup of water which comes inland. It doesn't go very far inland, maybe as much as maybe a quarter to a half a mile inland. But if you live within a quarter to a half a mile of a coastal area and you're hit with a very large storm surge, the damage is phenomenal. That was the case with Katrina. That was the case with Sandy of last year. Again, storm surge is the biggest issue with hurricanes. Storm surge, pretty simply put, is if the coastal area which you live on the slope of the continental shelf is very gradual, which most places which have beaches are, the storm surge comes up and creates a very large volume of water, and this volume of water may reach a height of maybe anywhere from maybe 20 to 25. In some cases, we had reports of Katrina where the height of the water level got up to almost 30 feet. So you imagine that if you have a two-story house and you've got a 30-foot wall of water coming at you, your house it's basically washed away. So it does, unless you take precautions, build the house up higher or somehow mitigate that water, get that water to go around your house. But again, water is extremely difficult to deal with these kinds of situations. Your coastal area is more like a cliff. The storm surge is not as big because your continental shelf does not come up real gradual. So those places like Miami, for example. Miami, the continental shelf comes up abruptly into South Beach in southern Miami. So they can actually put up with a much stronger storm surge, let's say a place like Charleston, perhaps like we saw with New Jersey then. Now, who's at most risk? Again, all these metropolitan areas are very close to the coast. If a storm comes into these areas, if a hurricane, major hurricane comes into these areas, or a storm with a large storm surge like Sandy comes to these areas, these are the homes that are in harm's way here. So again, the amount of impact is just phenomenal with these things. Another issue, of course, is oil refineries along the Gulf Coast. These have to be shut down when a tropical cyclone does impact those areas. So that is a loss of production. That's the reason why the price of gas goes up if any tropical cyclone starts developing in the Gulf of Mexico. Inland flooding is something that's often overlooked because people don't, if you live 25, 30, several hundred miles inland from the coast, you think to yourself, oh, a hurricane's not going to affect me. But when a hurricane moves inland, it brings a high volume of water. That can cause major flooding. In fact, it can cause flooding in places where you normally don't see flooding. So again, inland flooding is another issue you have to deal with. Damaging winds, again, are the big thing that people think about, but it kind of plays second fiddle to the actual damage that you get with the volume of water. But still, when hurricanes first come inland, right along the coast, the hurricane force winds will cause major damage. Once they move inland, then everything kind of spirals out from that. You start getting into tornadoes. We had 10 to 15 tornado reports just from a wimpy storm that we just had, Andrea, that across Florida. So tornadoes become the next problem once a hurricane moves inland. On the outer periphery of those hurricanes, you not only get tornadoes, but you also get hail and also localized damaging winds. Hailstorms don't usually occur within a hurricane once making landfall, but once it moves inland, it produces severe thunderstorms which can build up high enough to cause major hail problems then. Now, let me show you some images before and after Katrina. This is pretty typical of a house that's standing there and after Katrina hits. This speaks for itself. I don't need to say much about that. Also, when you have major flooding, whether you live near the coast or close to the coast, again, your businesses, your ability to travel is basically shut down entirely. Those things floating in here, these are actually semis floating through a highway. This is US 59 through Houston during Allison. That's a 6-lane highway right there underwater. Now, as I said earlier, one of the biggest issues that we're dealing with right now is because of the fact that the Atlantic Ocean has been so much warmer than normal because it's going through a 40-year cycle of warming, we've had a huge increase in the number of tropical cyclones. Now, these include tropical storms and hurricanes combined. So notice the number. If you recall back during the 70s, the Atlantic water temperatures are actually running cooler than normal. We had an average of 10 tropical cyclones, number of hurricanes roughly 5.6. But once we got into this warming of the Atlantic, because of, I'm not going to go into the science behind that, those numbers have jumped up pretty good here. So again, that's another issue because if you increase the number of hurricanes or tropical storms that affect the basin, the odds of you being hit are even greater. So I did a little calculation just recently, and on average, since the Atlantic has warmed up, the average impacts in the United States are roughly around 3 to 4 per year. Normally, before when the Atlantic was cooler, those impacts were only about 2. So the impacts have almost doubled from what they were back in the 70s then. Here was the hurricane season from last year. We had a total of 19 storms. Again, this has been a pretty common theme that we've had several storms hit in the basin well above normal from what we were used to back in the 70s and 80s. Notice again how many of these storms, though, did occur out in the middle of the Atlantic. Again, because of technology, we're now able to visualize more of these storms out in the far Atlantic. So that also brought the numbers up as well. But the impacts, we did have 4 impacts last year. So now the question is, how do we mitigate the hurricane damage? Well, there's a number of things that we've seen over years and studies and so forth. It's become more and more clear, as is the tornado problem across the United States, that we need to change our building codes or at least bring them up to snuff with the technologies that we now have to help mitigate the hurricane problem. Again, flooding is a big issue. We want to build smarter and stronger homes, or more smart homes. In other words, if you live on the coast, you may want to build them up a little bit higher. Take a look at this image through here. You can't see it very well, but this is a house. This is the Bolivar Peninsula here, just to the north of Galveston, just before Ike hit. And only those houses that were built up on pillars, on concrete pillars, survived Ike's destructive storm surge, which was about between 20 and 25 feet. So we know that if you build your house up off the water, you can certainly build a smart home that can deal with at least a water problem. Better drainage, the levees that we have not only in New Orleans, but there are levees all over the coastal areas that were built after World War II. Those need to be looked at, and a lot of places may flood, or those levees may give way if we don't take consideration. We need to modernize utilities. Some utilities are vastly under upgraded, so we need to upgrade those as well. Again, the other thing that we have to look at is preparedness. Secure your home. What are you going to do to secure your home, your business, and self? Don't wait until the advisories start coming out. You need to prepare way before that. We believe that now is the time that people should be preparing. You should be thinking of what we call a hurricane plan. Look at what's your insurance coverage. What will your insurance cover versus what will it not cover? What is your deduction? What's your standard deduction on if your house gets washed away by a hurricane? Again, how to have a plan in place of how you're going to react to each stage. When a hurricane watch is issued, what are you going to do? When a hurricane warning is issued, what are you going to do? How are you going to react to that kind of a situation? We, again, advise people, again, as you've seen on television shows and on news programs, people board up their windows, they put hurricane shutters up, and then get rid of debris around your house, locate supplies, and if you do have to evacuate, you're now being told that you may have to take your own water and your own food with you. That's a wise decision, because if you're in that shelter for more than just a few days, if you're in there for a week, 2 weeks, 3 weeks, the supply to that shelter may be substandard. So plan ahead. Think of the worst case scenario. Have plenty of water, have provisions all ready to go. If you have to evacuate, you're not going to be able to scurry around and get stuff together. You should have an evacuation plan already in place. Businesses need to also secure their situation. Board up the windows, get everything off the ground. If you're on a ground floor, get it up because water will come in. And even the spray from an actual hurricane, the sea spray, will get into computer systems. So you need to cover all that up. Also, do you have all your files backed up on a backup computer somewhere else? It's not going to be in harm's way. We're waiting to get those files and those important documents to somewhere where you can get a hold of them after the storm is gone. Because the biggest problem with business is you want to get back up and running as quickly as possible. Even if your building is hurt, you can go somewhere else and maybe set up shop elsewhere then. So the plan is, your plan is, will you evacuate? If the storm's going in a certain path, you will have to decide on that. Now, the local government will tell you to evacuate, and we advise you to follow your local government because they know the roads, the routes, and how long it's going to take for people to evacuate. So know what you need, and again, don't forget your pets. Now let's talk about the forecast. Well-behaved storms, we can forecast those pretty well, but as that slide I showed you earlier, sometimes storms move in an erratic way, so we sometimes have to re-look at how these storms set up. Forecasters have trouble determining how strong a hurricane is beyond 24 hours. But the big thing now is our technology has allowed us to communicate much better. The big problem right now is getting people to react properly to the communication we're getting to. We still need to evaluate how we communicate to not only one area, but maybe several areas. It could be the way we communicate in one area may be different in another area. So a lot of people have been put in harm's way because of where they built, but because of communication, we've been able to get them out of harm's way because of advance warning. Now let's talk about the AccuWeather Atlantic hurricane season forecast here. The influences that we're looking at again is that warm water. We're still in that 40-year cycle, what we call the Atlantic multidecadal oscillation, where the water temperatures over the next another 10 to 15 years will be above normal. We do not expect any El Nino or La Nina to impact the Atlantic basin this year, which means if we had an El Nino, that would bring strong shear, would also cut down a number of storms, would also prevent storms from intensifying then. The main thing we look at is certain regions of the Atlantic to see how the warm water is setting up, and that tells us how primed the actual water temperatures are, because water temperatures are one of the biggest factors that help drive hurricane development then. And as I said earlier, lower pressure also helps that as well. I just updated this slide a couple of days ago, and here's the actual water temperature anomalies. As you can see, this is where 85%, this rectangular area is where 85% of all tropical storms and hurricanes develop in a given year. So if we can get the idea of how the water temperature is in that general area, then we can certainly get an idea of how the season is going to progress. Now, I have to admit that we are seeing some cooler water to the north of this, and even eating away off the coast of Africa through here. So cooler water can certainly cut down on a number of storms, but being this early in the season, sometimes we will see some oscillations in the water temperatures. But for the most part, we've seen consistently temperatures averaging above normal so far this season. The AMO, I don't want to spend a lot of time on this, but simply put, we're in this 40-year cycle where the water temperatures have gone up. As you can see on this graph through here, this will continue to stay above normal. Water temperatures will stay above normal over the entire basin for another 10 to 15 years. And then unless global warming does have an impact, which is still a debatable situation, if the water temperatures do cool off, as some scientists believe, then we will see a decrease in the number of tropical cyclones in about 10 to 15 years then. Now, I just want to show you a couple of computer models which kind of bolster what we're looking at here. Again, the reds here would indicate above normal water temperatures across the Gulf of Mexico. And this is a model from the Japanese Climate Center. And again, it shows reds here, shows this main developmental region where most tropical cyclones develop, again, being above normal. Another model we look at is the European model. It's not as robust with the real warm water. On average, it's showing temperatures to be slightly above normal, or in some cases a little bit below normal. So this is, again, we look at multiple models to get an idea of how the climate models are suggesting. We also look at signs of where maybe storms may be heading. This is a forecast that was issued from the Japanese model, and notice how it actually pegged this pretty well. It actually said that during the early part of the season that we would see above normal rainfall. We had Andrea occur through here, so it actually is still showing that we should see above normal rainfall over much of the Caribbean and Florida. So we're kind of seeing that is an area to keep an eye on for possible impacts. And again, going deeper into the season, the same model also shows the same kind of a signature. Another model from the UK Met Office from England also suggests above normal rainfall over the southern portion of the Caribbean and also the southeast U.S. So we watch the trends in these to see how these react. Another thing we look at is the upper level winds. Upper level winds the last 48 months has been against development or has hindered development, but that changes because this value through here is going positive. This is the QBO, and these are going back to the right winds. These winds should help tropical cyclones to develop even better. Another thing we look at is shear, and the shear is low in the southeast and southern part of where tropical cyclones develop. That's a positive sign, and if this continues, we should see a lot of tropical development off the coast of Africa that will move westward. We call them Cape Verde storms this year. Now, we also look at past years to see how they compare to what we are currently in climatologically. The year 2000 was very similar to what we're thinking right here. Again, we kind of look at these to kind of give us an idea of how the season is going to unfold. During 2001, we also had an early season Gulf storm, but that was Allison that caused phenomenal flooding in Houston. We had Andrea this past week a week ago. It caused some flooding, but the damage wasn't nearly as bad as what we had from Allison. We picked 52, but back in 52 we didn't have satellite information. We believe that those numbers probably would have been higher if we would have had satellites to look at. So our forecast then, we're calling for 16 storms altogether, 8 hurricanes out of those 16. And out of those 8, 4 we think will become major hurricanes, again, category 3 or higher. And we believe basically 3 U.S. landfalls. This would be from either tropical storms or hurricanes. Now, if we do have another landfalling tropical cyclone in the United States later this month, we may have to bump that number up to 4 because the numbers and the way things are building across the Atlantic is what we're looking at. So you can see, compare that to the NOAA forecast and also the normals, or actually last year, and also the season normal. The reason why our numbers are lower this year compared to last year, even though the conditions are similar, is because we had 2 storms in May. We didn't have any storms in May this year, and if we, like I said, if we have one more storm in June, that would pretty much match up with what we had during 2012. So that would bring the number up to around 17. So that's the reason behind the madness of the numbers. So we are expecting 4 major hurricanes. In some years, we can see something in the model output that gives us an idea of where these storms are going to go. This year, it looks like the whole coastal area from Brownsville all the way up to Maine is going to be fair game as far as any of these major storms making landfall. Will all 4 make landfall in the U.S.? Probably not. It's very possible that all 4 major hurricanes may be out at sea, may not even affect us at all. That's where we look intently at more closer to the situation. We look at more regional computer models to give us an idea where that's going to happen. I want to remind you, the size and the speed of a tropical cyclone, again, determines how big of an impact it's going to be. A large but weak tropical cyclone, like we had with Sandy, can cause just as much damage as a Category 3 hurricane. So those numbers, Category 1, 2, and 3, are misleading sometimes if you have a huge storm. So keep that in mind when you're looking at this season or the upcoming seasons. One of the questions that I've been asked, could we have another Sandy-like storm? I'd say the track of Sandy was very unusual. The odds of that happening again this year or the next several years would be highly unlikely. But impacts from a large hurricane causing a large storm surge, that is definitely a possibility in any given year.
And now we'll pass it over to Claudia Dent.
All right, hello everyone, and thanks, Dan. That was great in terms of really giving us a background on hurricanes and severe weather, and certainly sobering on many fronts. One of the things that we're going to discuss today is, how to manage communications during an event like, massive hurricane like Hurricane Sandy. And let's just take a step back, and from an Everbridge perspective, during Hurricane Sandy, during that event, so that multi-day event, we sent over 10 million notifications. Now, 23% of those were actually sent during the storm itself, which really means that the remaining 77% were sent before and after the storm. And that really echoes a lot what Dan was talking about in terms of making sure you're really well prepared for a storm and making sure that you have a communication plan for handling the aftermath. Just a point of interest here is, the number of notifications represents a 156% increase over Hurricane Irene. And also, because of, the history around some of these, hurricanes and the severity, we saw a 31% increase in citizens opting in to be notified during the course of the hurricane as well. So, from a notification perspective, there's a lot of different important dimensions to why effective communications is important. Of course, the primary one is all around protecting lives, whether it's citizens or employees. And And also being able to protect as much as possible the continuity of operations. Being able to coordinate before and after mobile teams and people in the field who will help respond to any issues that arise, etc. These are all important dimensions and requirements for effective communications. But during the course of an event like a hurricane or any kind of an emergency event, all kinds of challenges can arise if you're not really prepared. First of all, if you have to do some kind of emergency notification during an emergency, that's a lot of pressure that you're typically under, and it's easy to make errors. Oftentimes people may not be prepared. They don't have the right contact lists ready. They're dealing with too many different inconsistent systems and processes, etc. And also just having limited access to frontline intelligence. These are all things in terms of challenges. The other half of the equation is once you can deliver a message that's accurate and fast, etc., how can you really be assured that the right people have received the messages and have the right people been notified? And can you really prove that during an audit situation? So those are the other half of the equation. So at Everbridge, what we really aim to provide you with is the ability first to have smart delivery of all notifications. And that is combining both speed and also providing you with the most frontline intelligence as possible. And of course, being able to ensure that you are connecting and confirming with the people that you're trying to notify so that you're assured that you're actually getting the responses from your team, whether it's citizens or employees. So let's talk a little bit about automation and speed. It's really important to have a user interface that's easy to leverage in terms of a single-page notification process, one-click sending, etc. But all of this doesn't underestimate the need to prepare ahead of time. It's incredibly important to have message templates and contact lists all ready to go to reduce errors during the course of an emergency. These are all very important elements to have prepared ahead of time. Also, the more intelligence you can get around a particular situation, the more accurate your messages will be that you're sending out to your constituents. So one of the key things that Everbridge delivers is this notion of visual intelligence. And there's a number of dimensions to that. First of all, it enables you to actually select your contacts using the map. So you can increase your accuracy by pinpointing a zip code, a particular address, a radius. You can have custom shapes. If you know there are certain zones that are more important than others, you can have those all ready to go. And most importantly, pertinent to this discussion, is that within the context of our visual intelligence, we also offer over 100 different kinds of weather alerts and map-based tracking. So this gives you very accurate polygons for things like tornadoes, hail, thunderstorms, any kind of blizzard conditions, and of course, hurricanes as well. And we're going to look at some actual screenshots coming up. So in addition to understanding as much as possible about weather, there's a wealth of information that's available from a social perspective as well. This is the age of social media. But the question is, how do you harness that information that's being, developed in social situations with tools like Twitter, etc., because the volume of Twitter feeds is so enormous that it's hard to really get at the information that's most pertinent. That's why Everbridge provides a filtering mechanism so you can view the Twitter feeds and the tweets that are most important to you and a particular situation that you're tracking. And we'll look at some examples of that in the coming screenshots. Likewise, Everbridge also offers a mobile member application which enables you to communicate in a two-way fashion with your constituents, enabling you to get pictures from the front line of specifically what's going on, etc. So, let's delve into weather a little bit. We're not done yet. We're never going to be done with weather. This was headlines taken right before the worst of the tornado struck Oklahoma. Unfortunately, later on that afternoon, the worst of the tornadoes struck. So we know, always, unfortunately, that there's more to come. This actually shows you a screenshot of the Oklahoma tornado watch, and notice the detailed polygons that are structured around that tornado watch. Leveraging Everbridge, you can target communications to all of the employees or citizens, etc., that are in those particular geographic areas. You can do that automatically and have the whole system automated, or you can provide additional communication on the fly, etc., as you feel is required. In addition to that, this is an example of Hurricane Sandy, and you'll see again the polygons that are developed around Hurricane Sandy, and where the worst of the wind was going to strike, and the damage along Connecticut in particular and the East Coast. And so we work to protect those citizens and employees and companies and assets by having the most up-to-date weather information and combining that with the ability to automate communications. Let's talk a little bit about social intelligence during the course of the of Hurricane Sandy. I think one of the interesting things is that during the course of the hurricane, it was fairly scary, and there's a lot of tweets going on, etc. But during the aftermath, some of the communication and social intelligence was even more important. And a great example of that is some of the hospitals that we work with were trying to staff their various shifts after the hurricane, and many of their staff ran into problems because gas stations weren't open and lines were really long, etc. So by having access to some social media, you could tell which gas stations were open, which ones had run out of gas, so you wouldn't get stuck in a long line for no reason whatsoever. But this was the kind of information that you can leverage on the front line in any kind of unexpected situation. And not only that, from a social intelligence perspective, people were starting to take pictures when they left their homes right after when they started to venture out, and you could see some really dangerous situations evolving, and having access to this kind of information is really critical as you plan your recovery, and you figure out, well, where should I focus my attention? Where are the most critical areas that need attention? And social media can provide a piece of that puzzle. It's never the be-all and end-all, and sometimes you have to be careful of rumors, etc., that spread on social media. In fact, you might want to use social media as a way to make sure that citizens don't pay attention to false rumors, etc. So leveraging the valuable information that's with social media, as well as getting clued into some false information, are both equally important in terms of communicating with constituents. We all know emergencies don't happen 9 to 5. So the ability to launch an emergency notification wherever you are with the same richness of the Everbridge platform is also critical. So we provide a mobile manager application that enables you to access, any of your templates, reporting and dashboards on the progress of notifications. You can leverage the same map-based capabilities and select contacts on maps, all from your mobile device, whether that's a tablet or a phone. The other critical aspect of emergency communications is really targeting the individual and trying to reach people in a way that is most effective for them, but also ensuring that you have multiple delivery paths to improve message confirmations. During the course of Hurricane Sandy, one of the first things that happened in the state of Connecticut, as an example, is all the landlines went down, and you really couldn't get a hold of people leveraging landlines. So it was important to have backup means of communicating. And what Everbridge does is it looks at people's delivery methods and what they've provided as their priorities, and it enables you to, try a first attempt to reach them. If they don't respond, it just keeps going down that different delivery paths until, people have confirmed. And you can always resend a notification to those people who have not responded, and you can keep resending that until you, get a desired response. So that goal for really targeting individuals, aiming for 100% confirmation, is the goal of the Everbridge system. Likewise, we have access to rich information via two-way mobile communications. So this is an example of being able to send a polling notification and asking someone, hey, are you safe? Are you hurt? Are you near the area? Are you outside of the area, etc.? And also, not only that, being able to get a picture of what's happening, whether it's a fire, a weather emergency, etc. So you're getting, as the emergency provider, you're getting the most up-to-date information on what's happening on the front line. So from an Everbridge perspective, we really focus on smart delivery and assured response, and that rests on our platform. Everbridge has been in business for over 10 years, and over that time period, we've really developed a set of best practices. These are all available for you to get a look at in our Everbridge University. That is part of our solution. So it's not just a product. It's really about enabling your success beyond just product capabilities. And we won't go into the details in this presentation.
Actually go into the details of the product line here. You can certainly reach out to Everbridge to get those details. But I did want to make a couple points in the sense that the suite is a series of very tightly integrated products that rest on a unified platform, all leveraging our 10 years of best practices, etc. So, as we think about the capabilities here, one of the key things that everyone should be aware of is that, Everbridge really has over 1,500 customers. So, these customers range in a variety of different verticals. So we serve, corporations, hospitals, state and local governments, education, transportation, etc. So I would encourage you to reach out to learn more, about Everbridge and understand how we can help, address your specific emergency communication needs. So with that, I think we're going to move to the question and answer session, and I'll turn it back over to Erin, who will be our MC for the Q&A. Thank you, everyone, for attending. We really, really appreciate it.
Perfect. Thank you so much. So we have just a few moments, so we'll try and get some Q&A through. Just as a reminder, you may submit your questions by typing a question into the open field in the questions panel on your screen, and submitting to all panelists. And if we don't have a chance to answer your question on the call now, we'll have someone follow up with you after the presentation. So the first question is actually for Dan. Can you talk a little bit more to what caused the loss of lives at Katrina? And is New Orleans susceptible to similar damage from another hurricane?
One of the biggest problems with Katrina was just getting people to react.
Dan, you might still be on mute.
Oh, let's see here.
Great, Dan, we can hear you now.
You can hear me? Okay, good. One of the problems with Katrina was the fact that local government and the people themselves just did not react to the ferocity of the storm. I think a lot of people underestimated just how powerful the storm was. When they saw it was moving north and weakening, they said, oh, it's going to weaken, so we're going to be able to deal with the situation. And I think part of the problem was I don't think local government properly was prepared for this. Now, the levees gave way because of the increase in water level into those levees, and basically those levees gave way, and that caused a major flooding. And it's the process of the levees breaking down that caused most of the loss of life. Now, if those levees would have held, we would have not had nearly the loss of life that we did. And so, again, I would say that the communication, getting people out of harm's way, was fairly good. The problem is not enough people reacted fast enough. And this is the reason why we ask people nowadays that when a hurricane is coming to a major metropolitan area, they have to react. They have to plan way in advance. If you know an area gets flooded, look at the worst-case scenario. Get those people out. It's a much better chance of lowering that loss of life.
Great, thank you. So this question is for Claudia. Can different notifications be sent out simultaneously to different recipients? For example, public versus first responders, and based on who they are?
Yes, absolutely. You can customize your notification templates to have, two different messages, one that may be more appropriate for citizens and one that may have more pertinent details for emergency responders. And you just tailor the contact lists for those particular notifications. You can group notifications in events, so you can actually see as part of an event like Hurricane Sandy, who you sent notifications to, what the content was, what the response rates were, who confirmed, etc.
Great, thank you. So this one is for Dan. When a hurricane moves inland, what's more of a concern? Damaging winds, flooding, or both?
Flooding is by far the biggest problem. The winds usually weaken as a hurricane moves inland, but there are other things of other parts of a hurricane that cause issues. Hurricanes do cause tornadoes to spin up. So in a roundabout way, wind is also an important thing. But as a hurricane moves inland, the winds drop off quite a bit. It's those outer periphery parts of the hurricane, like flooding rainfall and tornadoes, and even damaging thunderstorms. Sometimes we'll get severe thunderstorms with hail and damaging winds on the outer periphery of those things. So when a hurricane comes inland, it unravels and affects usually a much larger area.
Great. So we'll finish up with one question that I believe is appropriate for both Dan and Claudia. How do you combat public desensitivity to storm warnings? So we're seeing people become less and less concerned with hurricane warnings and waiting until it's too late to evacuate. How do you both change the frequency of alerts and the messaging to make sure that people take storm warnings seriously?
I think one of the ways we can do this is to better communicate the threat. I think if people understand the threat and how to plan for the threat, that's the main thing. But communications by far is the big thing, not only planning ahead, but also in the height of dealing with the situation. You need to have that device, you need to have that ability to communicate with yourself, with those in harm's way, and perhaps if you're in a business, you need to be able to communicate to other people what they need to do to get out of harm's way.
Yeah, and I completely agree with that. It's critical to communicate very specifically, you know, what actions to take. And I think part of that communication, you know, really making sure people understand the seriousness of the threat is really important. And one of the guidelines we use is the 3-3-30 rule, which is 3 ideas, 3 sentences, and, you know, roughly 30 words. That's basically what people can, you know, kind of consume, so to speak, in an emergency situation. But if you're very clear on, you know, what the threat is, you're more likely to get response.
Great, thank you so much. So at this point, I'm sorry to announce we've run out of time for the Q&A session, but thank you to Dan and Claudia, and especially thank you to everyone for spending a few extra minutes with us. This was a great session, and we're very excited that everyone was able to join us today. If you missed any part of the webinar, be sure to look for the slides on blog.everbridge.com, and you'll also receive an email with a link to the recording in the coming days. If you haven't already, please take a moment to follow us on Twitter at @Everbridge, and join our group on LinkedIn, Emergency Incident Management and Emergency Notification Professionals. For those of you interested in seeing a demo of the new Everbridge system, please visit everbridge.com/contact-us to request one. Thank you all again for your participation in today's presentation. Hurricanes and Hail, AccuWeather's hurricane expert helps you prepare. We hope to see you online again soon. Have a great day.